Hey everybody, hope you're all doing marvelously okay. So today I'm going to be working on a Samsung phone. This is a Galaxy S22 that was sent in here as a mail-in for no power. The customer says, phone is dead, no power up or any indication of charging. Phone was in my back pocket when I fell backwards and sat on it pretty hard. No cracks or any damage is visible on the phone case. It was in a leather case with a fold-over front. Recovery of data is not required. I have a new A14 phone that has been restored with most everything I need. Photos had previously been backed up, blah, blah, blah. Okay, he's just saying he does not need data, and this customer has requested a video, which I normally don't do upon request, but here we go. So here is the case that this phone was in. It's actually a pretty nice case. And a bit of a confession, I have already removed the back from this phone. And this phone, it is just, this thing is spotless. There is no sign of bending. There's not hardly so much as a crack on the screen. We don't have any cracks or any marks on the back glass, which, by the way, that's a pretty stinking clean removal, isn't it? So I'm going to bring you up to speed as to what I'm finding here so far. I have, of course, removed the back glass. And I have taken off this one cover here, and I'm going to show you what I have done here to begin my diagnosis process. So when this phone is hooked up to a USB current meter, you can see that it is only drawing 800 milliamps or 100 milliamps at 5 volts. Now, the very first thing that I do with most Samsung phones is I, of course, disconnect the battery like that. And we need to get hooked up to this thing with a DC power supply so that we can find out exactly what it's drawing from the battery terminal itself and not from the USB, not through the USB port. So whenever I don't have a DC power supply lead handy, and on Samsung phones that have an antenna flex cable, I like to just hook right onto the ground shielding of that. But on this particular phone here, I'm just going to go ahead and hook it right up to this little thingy right here. That's our ground probe. I've got the power supply set to 4.1 volts with a current limited to 3.2 amps, which is not limited at all, really. So for our positive lead, I'm just going to get right in here and touch it with a meter probe. And as you can see, this thing is drawing an immediate 50 milliamps of current. And if we push the button to boot from here, I suspect absolutely nothing will happen. I'm clicking the power button on the side of it, which gives us absolutely nothing. So we have 50 milliamps of current at the battery line, and pushing the power button does nothing. Now, those of you that work on these phones knows that 50 milliamps of current at the battery terminal, that means that we actually have a main short on this board. It's just not the actual main battery line. It's a line that's just under it. Now, the problem with this phone is that I don't actually have any schematics for it. I have a board view for the S22 Ultra, but the just straight S22, I have virtually no information to go by. So I'm going to get the board out of this thing and see what we can figure out. Yeah, and we'll just hope and pray here that these connectors don't fall apart when they're unplugged. I don't know what it is about these Samsung connectors, but they tend to just sort of fall apart. I get a lot of these in here for repair. There we go. There we go. All right, so there we have us a beautiful, and I mean beautiful Galaxy S22 board. The board looks pretty well spotless. There is not any indication as to what in the heck has went wrong with this thing. We want to make sure and unhook all the cameras. We're going to disconnect everything from this board that we can. Boy, that one almost looked like it was already disconnected. So there we have our little camera cluster thing removed. And I'm just going to try to leave that all in one piece and not move them around. Ah, dang it. Well, so much for leaving it all in one piece. All right, we'll go ahead and set that aside. Now, since I have no schematics here to go by, this will be a little bit of a wild goose chase. Now, my main fear here is that this short is going to be somewhere inside of the logic board sandwich. So let's get right down to it then, shall we? Let's see if we can find a short on this thing. I'm going to be setting my multimeter to diode mode. And with diode mode, I will be putting my red probe on ground, and I'm going to use my black probe to do the probing. So if we check at the battery terminal itself, and we touch on the ground side, you'll see here that we are getting a 0.002 voltage drop to ground. That's 0.00 volts DC of difference. And then if we look on the positive side, we're getting a 0.49, 0.5. That's actually a completely normal reading. So being is that I do not have schematics for this board, it's going to be a bit of a guessing game here to find something on one of the main power lines. You know, I have to find it on the next power line down, and it is a main line. I just don't know what it is on here. I believe on the schematics with Samsung boards, it's the difference between VBAT and V battery. Like, they're not the same line, it's different. It's on the other side of a chip that actually creates it. So again, red probe on ground, and I'm just going to start poking around here at random. There's a 0.002 on this side of this one, 0.6 on that side, that's a normal reading. Open line on this one, that's completely normal. I could probably look at a similar, find a board that's similar and use that as somewhat of a reference. All right, let's check this capacitor down in here. I'm not actually trying to find the exact short itself. I'm only trying to find something I can get on to check for a short, and we can use this one. And on one side of this capacitor right here, we are getting a 0.00, and then on the other side of that capacitor, we can plainly see that it's actually ground, like it's hooked to the ground plane itself. So the inside of this cap right here, that should not be 0.00. That is a short to ground. And I know from experience working on Samsung boards that that's going to be our second battery rail, V battery or VBAT, whatever you want to call it. So we're going to use that line to check for a short. And to make this a little bit easier on myself, I am going to go ahead and solder me on a wire. Oh, Lord. Look at the size of that blob of flux I just put on there. Oh my goodness. All right, so let's get us some solder down in here. We're going to solder to the side of this cap that I knew is not ground, which is this side over here. There we are. We got us a nice, beautiful anode soldered on there, right? And now I need to find a spot where I can pretty comfortably clamp on ground. Let's see, where can we do that? Ooh, let's clamp it. Let's clamp our ground right there, shall we? So for the ground probe, that is going to get clamped right there. And then for the actual power coming in, we're just going to clamp that onto that wire that I just soldered on. This is magnet wire. It's actually coated in an enamel coating, so it can be touching things and not shorting it out. So then, here we are looking at this board with thermal imaging. Now, we're going to be paying attention to the current meter over here on the right. That is the channel 2 on my power supply. And I'm going to turn the power supply on and watch very carefully here for things to get hot. We know that the wire that I had this hooked up with is going to get hot because it's tiny, but I'm hoping that this is going to reveal where at on this board the short is. And furthermore, I'm hoping that this is not a short inside of the sandwich. So here we go. 1, 2, 3. On. Nothing? What? What have I done here? Did the wire come off? No, that wire's still on. Must be a ground problem here. Let's try again. What? I bet you the screw hole that I'm clamped to is not actually ground. Okay, so I'm now going to try to touch the ground to one of the shields. I get nothing? Oh, that wire's coming off. All right, so I'm going to clamp the ground back on, and just to make sure I'm not barking up the wrong pole here, I'm just going to go ahead and touch where I had that wire soldered on with a probe and make sure we are drawing some current before I do this again. All right, let's try all this again. So this time, I'm going to be clamping my ground on right there to where we got it clamped onto that shield, but then nothing on the other side of the board. That's nice and pretty. Before I go soldering a wire on, I'm going to do a test run here, and I'm just going to touch this capacitor down in here and make certain that this is giving us a connection. It is. Okay, so that draws 3 amps. All right, so let's get our wire soldered back on here. And you can see it actually pulled part of the end cap off of that capacitor. That's just going to be fine. Just going to have to be more careful this time because we're going to run out of places to hook it. Not good. All right, so I'm going to go ahead and get this capacitor out of here. That way I can solder directly to the pad. This capacitor, it's going to need replaced anyways because I've pretty well screwed it up. Trying real hard not to take that pad off of there because with a lot of main caps, I don't really care if that pad stays there. But in this case, I do. Because I don't know where else it goes, and I want to make dang sure that this stays good because I need this for troubleshooting. All right, so there we go. Now for the ground connection, it's going to go right here, grabbing a hold of the shield that's on the other side of the board. And then for our positive connection, it's going to go right here. And now let's have a look at the thermal imaging. I'm going to turn the power supply on. We're not going to pay attention to the wire right here that's going to get hot. We know that's going to get hot because it's a tiny little wire. Let's see what else we can see. Okay, let's watch that once more. It's going to be hard to see with that wire in the way. I'm going to say we've got an area out here at the corner of the board that's starting to get hot. I'm going to carefully try to turn this thing over and see what else we can see. Okay, so now I'm looking at the other side of the board. Now we're going to turn the power supply on, and 1, 2, 3, on. Okay, on this side of the board, it looks like it is just the wire getting hot. But also, again, out here at this same corner, so flipping it back over again and looking at the back side, I'm going to be watching this corner here. Let's see if we can maybe get that wire out of view. Let's just get the, all the way over here at the corner of the board. And here we go, 1, 2, 3, on. Yeah, we definitely have a short going on out here at this corner of the PCB. So at this point in the game, I would switch over to a schematic, over to the board view and look and see what it is that we have. But again, I don't have a board view for this one, so it's going to be a little bit of a wild goose chase. I'm going to be needing to look under this corner of the shield out here and see what it is that we are up against. So then, back under the microscope, I'm going to try to peel this cover up off of here and see if it's a board where we can just look. I don't think it is. This board's going to have, there'll be openings like above the memory and the CPU and stuff, but it's not one I don't think I can get to that spot without removing this shield, is what I'm trying to say. So I'm going to remove the sticker here from the bottom. Oh, look. Yeah, let's get this sticker off of here. You can actually see as we do this, under that sticker, there's an area of this shield that's dented in. Like this whole shield is dented in right there. Oh yeah, the whole shield is dented in. That's a really ugly, that's a really bad sign, if I'm being honest. All right, we got that pesky sticker removed from the bottom of here. And the spot that we're getting heat, it's right down here at this area down here. And man, this whole shield down here is dented in. So I don't care one bit for cutting these shields, and I'm actually not going to start today. To remove this shield, I'm going to be using a stick of low melt. Now, this isn't like the low melt solder that I use for reballing stuff. This stuff will almost melt in your hand. In fact, it's probably getting soft just from me holding it. Let's see if we can get this shield off of here in a nice, efficient manner. All right, so to get this shield off of here, I'm going to set my hot air on, I set it on 340. I would not advise setting that high. That's just the way that I run it a lot of times. And I'm going to start by applying some flux to this thing and warming this whole board up. We're going to get flux around the outer perimeter, mostly. And the more flux I use, the more cleaning I'm going to have to do. We're not going to be able to get away with doing a significant amount of cleaning, so let's just go ahead and flux the total holy snot out of it then. The goal here is to not separate Samsung's ugly sandwich. Alright, so now I've got flux all the way around the entirety of this PCB. And now I'm going to show you what I mean by will almost melt in the palm of your hand. This board, it's so, I mean, I can lay my finger on it right now, and even without the glove, this board would not burn me. Like, there's hardly any heat here. So watch what happens when I take this low melt and just touch this. Look at it. It melts. So easy. So I'm going to take a bit of this stuff and just get it on the tip of my iron and start going around this board. I mean, around this shield. You actually don't have to get it everywhere because it will travel. This stuff melts so extremely very low that it will literally travel around this board. And on Apple PCBs, it has even surprised me. I mean, look, see how it's still melt? I'm literally just touching the board holder down here, and I'm going to leave a piece of it behind there and use that for dipping, like honey mustard sauce or something. There we go. Just very quickly, we're going to buzz around here and let this board suck up the low melt. No big deal, just casually dissecting one of the newest Samsung motherboards there are, just like everybody does. Okay, we want to be real careful here not to get this low melt on those components, because this is not the low melt that we can trust even a little bit on anything. This stuff melts so ridiculously low that you can smear it between your fingers while it's molten and not get blistered. Okay. That's almost the first side of the shield done. Yeah, with like iPhone 12 and 13 boards, you only have to get this stuff like on one side of the shield and just flux the total snot out of it, and you can just literally watch it travel around the shield. Okay, this shield is almost loose. I'm telling you, this stuff melts so low, it will surprise you. It still surprises me, and I'm expecting it to make this really, really easy. All right, so I think, I'm not sure because I've not taken this off of this board yet. I think that we are ready to start pulling. So might as well start down here at the corner that we know the short is in. And now to remove this shield, I'm just going to take my blade and get it under the corner here and start lifting up. And look at it. That whole shield's already coming loose. Looking good. This is the SRA fast chip alloy or something here that I'm using. It makes these things melt so very low. Like, it is absolute true low melt. There we go. We have us a beautifully removed Samsung shield. And now then, let's have a look at this end of the board where we know the short was. Please, don't be inside the sandwich. So, having a look at this under the microscope now, we're going to zoom right on in and look at this corner of the board. Oh boy, I do get a little bit nervous seeing this gigantoid inductor sitting here because, well, those have the tendency to get hot when something on the other side of them is shorted, and I'm really hoping that our short is right here. So let's just have a look at that with the meter one more time. I'm going to just peck around here and sort of hoping that one of these big capacitors that I can see is going to be the culprit. So I'm going to put my red probe on ground, and I'm just going to poke around here at these caps here at the corner. And I'm kind of happy to get a 0.00 on one side of that one, and then on the other side, my chances of the problem with this board being located like right here, they just went up quite a lot. So Rather than doing any guessing, I'm just going to do this with a thermal camera one more time. So here we are with the power supply on the screen. Again, look at the channel on the right hand side, and we're going to turn the power supply on in 1, 2, 3, on. Ugh, that don't look very promising, does it? I'm worried that that was down inside the board. All right, so having a look at this quite a bit closer, I'm going to turn the power supply on, and 1, 2, 3, on. Ooh, look at there. Did we just get lucky or what? All right, so we've got big inductor on top, 3 caps on bottom, 2 vertical and 1 horizontal. 3 caps on bottom. One more time. All right, so we've got that cap there. So then, switching back under the microscope, and we have a look right here at this area of the board. There is what we are seeing on thermal imaging. We've got the big inductor on top, 3 caps on bottom, 2 of them vertical, 1 horizontal, and the one in the middle is the one that is blasting off the thermal signatures. So to get rid of that cap, and also to get rid of the crappy alloy that I now have all over the tip of my beloved iron, I'm going to just flood that with some leaded. There we go. So then, back under the microscope, I'm going to put some flux on that. And then I'm going to use the tip of my iron with some nice leaded solder on it to start getting rid of this lead-free garbage that is on this cap. Boy, that iron looks... Let's clean that off a little bit. All right, so let's just get us some leaded solder on here. Get that cap out of there. Now, I don't know exactly what the value of this cap is. It's likely somewhere between 2.2 microfarads and 15 microfarads. And also, if you notice, right here nearby is all this really, really, really ugly low melt. I like the stuff for doing work and taking shields off easily, but we're not going to be able to use it to put those shields back on. And I'm not going to be able to have any components accidentally soldered with this. So I will be using my iron to remove this garbage, and it is garbage. It's not any good for doing like useful loads. So for now I'm just going to clean it off of this spot here because I don't want it getting on the solder joints for this brand spanking new capacitor. All right, let's make sure and get this switched over to an alloy that is useful for something other than tearing stuff up. Okie dokie, so let's get us a not so brand spanking new capacitor and get that put down in there. I'm just going to warm this up and let this thing fall into place. I'm setting my hot air on 340 degrees with an airflow of 4T. And the solder on this cap will melt quite a bit sooner than everything else around it, so that'll be handy. Still want to heat very evenly because I don't want to accidentally disturb this board sandwich, which is pretty hard to do on this model. Alright, there we go. The capacitor has installed itself quite nicely. And I'm going to go ahead and soak up while the board's still hot. This is leaded solder that I accidentally put right here on this shield joint. That is no good. That'll have to take way, way too much heat for me to soak that up. I mean, for me to sit it down on there, which I do plan on putting the shield back on. Alright, there we go. Alright, so I've got most of the flux cleaned up off of there. I'm going to remove my little test lead here and go for a quick test at the battery terminal. So let's get rid of the test lead, and then also I need to install a brand spanking new capacitor here. So we have this little piece of little piece of a terminal off of the old cap stuck to the board. We need to get that out of the way. There we go. Now we're left with nothing but a nice, beautiful pad. And now I'm going to take a brand spanking new 6.4 volt, 2.2 microfarad capacitor and solder it here. I think that's what I'm installing here. I know it's at least 6.4 volts anyways. And again, we're going to wait for this capacitor to solder itself onto the board, which it'll do as soon as it gets hot enough. Come on, baby. Don't blow away. I'm running out of you. Any minute. Oh, it's already... That's a good way to overheat it. It's really important to pay attention to when that solder melts, because if you go too far, you can actually overheat things. So, one more time. Now with some flux on the board. And I don't have this board in a holder right now, so the mat underneath keeps swelling and changing my focal point. So it's very, very difficult for me to keep this in focus. But we've got this capacitor now soldered on here nicely. There we are. We're going to stop right there and leave it alone and not nitpick. So I'm going to check this thing now with a power supply. I'm going to hook up my ground, and then I'm going to touch the battery terminal to make sure we're not getting still 50 milliamps. So here we have the power supply on the screen, and paying attention to the right side channel. And I'm going to go ahead and just touch our positive side now of the battery terminal. So right here, positive terminal, we want to make sure that we're not getting a steady 50, which I'm sure that we won't anymore. We got a little bit of a draw whenever all the caps on the board charged, and then down to nothing, which is a completely acceptable reading. I'm going to take some solder wick, clean all the garbage that I put on this board off of here to remove the shield, and then I'm going to replace that with some of the stuff that I use for soldering the sandwich board, Apple sandwich board, back together. All right, so to clean this garbage up, I'm just going to take some ordinary solder wick, and there's our beloved replaced capacitor right there. And then right here you can see that my low melt did not fully dissolve into this stuff. It just did partially, so on that I'm going to flood that with the low melt that I want on here. I'm not trying to make it perfect. I am putting the shield back on here, that's the goal. Alrighty, so I have this thing pretty well cleaned up. I've got most of the flux off of here that I care to clean off of here. It's never going to be absolutely perfect unless I run it through an ultrasonic cleaner, and I'm not going to do that. That is, unless I plan on drying this board in an oven for like 15 hours, and I'm not going to do that either. So here is the cap that I replaced, and the one component that brought this board all the way to its knees. And you can see I've replaced all of the alloy around the outer perimeters here with something that is not near as brittle as the low melt that I used to take it apart. So to prep this shield to put it back on there, remember I blobbed low melt all over the outside of this as well. I'm going to be getting rid of that. I'm going to take some wick that has a good amount of flux built into it, and I'm just going to go ahead and suck all this up from around the outer perimeters using the inside of my hook here. Trying to be very careful not to leave any stray wires. So very easy, we just go around the outer perimeter here. And we use this wick to pull that garbage alloy up out of there. And it seems that the shield is cutting some of my solder wick. Let's not leave any frayed wires down there. And there, that'll be kind of nasty now, wouldn't it? And there we go. So now that shield, I've sucked pretty much all of the garbage alloy up that was on there that I used for removing it. And to put this back on, I'm just going to go ahead and flux the shield itself because it's easy. I'll just take and put us a bead of flux right here around the edge of it. Try not to get any big old blobs, but if we do get a little blob or so here or there, it's going to be okay to have some of this left behind on the board. After all, it is no clean flux, right? There we go. That's got us a nice bead of flux all the way around the board. Get it lined back up on there just about like it was before. And I'm going to have to go wash my hands here in a minute because this flux is all over me and I don't want to get it all over everything else. All right, so that's got that shield lined back up pretty much just like it was whenever I found it. So with my hot air set on 340 degrees C with an airflow of 40, I'm going to begin warming this up and try not to blow it out of the way. Now the alloy that I've put back on here, it's quite a bit more friendly than the alloy that Samsung put on here. It's not so friendly that it's going to melt from the phone getting warm, but it will allow us to put it back on there without potentially destroying the motherboard. There we go. I have got the shield all cleaned up, and I'm going to be real honest. I had some trouble with this thing not going down the way that it was supposed to be, and I spent a little bit of time off camera here and I actually re-soldered this shield, but it is on there nice and firm now. Now, since I don't have the actual stuff that I peeled off of here, what I'm going for here is trying to get a thermal bond to the outer shield with the top of the CPU. You know, we've got this thermal compound here that is only there so that the thermal energy can transfer to this sticker that's going on the top of here. So I'm just trying to reproduce that the best that I can. I'm just trying to allow the heat from the CPU, actually from the RAM on top of the CPU, to be transferred out to the shield around the CPU. I'm pretty well sure this thing would be fine without this because it's hooked to basically a solid chunk of copper on the bottom. But I don't know, you all me, I nitpick and I try to make things as good as possible. This part of it winds up facing down. And the only way to see this is if you actually take the motherboard out of the phone, so we're not going to worry about the appearance of this too much. I'm honestly just trying to get a thermal transfer from the RAM to the outside of the board here so that it has as much of the original cooling properties as what it had before. So there you have it. We have a nicely reinstalled shield with some kind of a sticker on top of it to transfer the heat to the outside. All right, let's set that board aside. Put my little beloved stick of low melt away here. Now, since I made a terrible, and I mean terrible, sticky mess here doing this job, I'm going to clean up the table here. Almost there. We got to solve the puzzle as to how these cameras go back on this board. Like that. Ha ha ha. There we go. So now I got all those cameras reinstalled on there. Now thankfully on Samsung phones, all the screws are pretty much the same size, but they always wind up throwing you at least one that's short, which we're going to put right here. So there we have it. I have all of the screws put back in this thing, and this phone has been fully reassembled from top to bottom, and we are just about ready for a test run. So now we're just going to go ahead and slap the backpack on this thing, which, by the way, I've already checked and cleaned the camera lenses to make sure I haven't left any funk there. All right, so here we go. I've done it again. A full reassembly, and I haven't actually test ran this. I really, really hope that the fall that broke this capacitor only broke that capacitor. So here we go. I'm going to plug the charger in 1, 2, 3. We are drawing 300 milliamps of current. We have a battery charging icon. This thing is going to be good to go. So the charging current, it's bouncing around off of, 600, 700 milliamps, 600, 700 milliamps. The battery inside this phone is going to be completely, totally flat dead. So you can see now we're drawing a nice steady 1 amp of charging current with 5 volts on the output. And the phone has still not started to register, any sort of percentage. So that says to me that this battery is still like super, super flat dead. I'm going to put this thing down and let it charge for a little bit, and I'll be back with you in a moment. Okie dokie, this thing has been charging for a little bit. It is now drawing 1.6 amps at 9 volts, which is just absolutely lovely. It has been doing this little drop-off thing down to a 1 amp and then back up to 1.6. It's been hanging at 1.6 volts, at 1.6 amps a little bit longer each time, so I'm pretty sure that's either due to the battery having been severely dead or possibly due to the way I have it hooked up. So then, I'm ready to have a test run here. I'm going to hold the button down and see if we can boot. It's at 16% battery. Zzz, felt it vibrate. Awesome. Samsung Galaxy. We got a Samsung logo. And this phone is going to be good to go. I'm going to give it just a second to boot here to make sure there's not anything crazy going on. I've also got to kind of hide the lock screen. Ooh, we got a T-Mobile phone. There you have it. We have a nice planty lock screen. It's at 17% battery. We have working touch, and this is a pattern unlock phone. And we have working sound. That's as far as I'm going to take it for now, because I actually do not have a passcode on this phone, and I don't plan on requesting one. So I'm going to leave this thing charged for a bit longer. Heat it up and clamp the adhesive nice and tight and seal it up the best that I can, and this is going to be a happy customer. Also, this is going to be the end of this video. So if you like my videos, please give me a big thumbs up. If you like this type of thing and you want to see more of it, feel free to subscribe. I'm going to be posting as often as I can, and I will see you in the next one. Have a good day, everybody. Thanks for watching.